So industrial organization is the study of how markets respond to environmental or policy changes. So the literature prior to us was mostly theory literature, and it was based on a lot of assumptions, and it was difficult to tell which assumptions were relevant where. What we did is develop the empirical tools that allowed you to do the analysis, allowed you to figure out what were the appropriate assumptions and then do the analysis. So an example would be, what would be the likely impacts of a merger or of a tariff change? And the models that we developed are able to predict these counterfactuals. Yeah, I'll do one on, so one set of works was reanalyzing the breakup of American Telephone and Telegraph, AT&T. And the question was, what were the impact? AT&T had been a regulated industry and a monopoly. And the question was, what were the impacts of deregulation? And we were able to show that the impact of regulation, of the actual regulation, had been a misallocation of capital. That is, capital was not in the most productive places. And when they allowed deregulation after several years, it was reallocated optimally and productivity went up significantly. And this became a template for the analysis of other regulated industries as well. So that's one. Another, which isn't quite an industry, but it follows from our work on industries, was we developed a way to improve the consumer price index in the United States. The problem with the consumer price index is that goods fall out of the price index, and the goods that fall out are disproportionately goods that are being obsoleted and prices are falling. So we developed a way of including those goods and analyzing the prices analyzing a more complete model of how prices changed in the economy. So that has been incorporated in part of how the Bureau of Labor Statistics computes the price index currently. One other example, we studied healthcare and the allocation of patients to hospitals. There are two ways of doing this in the United States that are prevalent. One is fee-for-service, where the doctor got a fee and the hospital got a fee for every service they provided. Another was called capitation, where you gave the medical group a capitated amount that for each patient. And you asked the question, if the medical group spent all the money on the patient, didn't spend all the money on the patient, they got to save some of what they didn't spend and keep it for themselves. So the big question was, will this cause doctors and hospitals to skimp on quality for price? And when we estimate it, we find that what doctors do is, doctors that are capitated do send people to cheaper hospitals, but they don't sacrifice quality of hospital. What they do is they send them to less convenient hospitals that are equal quality, so maybe farther out of the city or someplace where it's not as costly. Yes, here my work was mostly data work. So what we did there is we brought down data sets on patents of individual firms and related it to the R&D activities of those firms. So that was one type of thing. After we showed how you could access the patent data, a lot of people use the patent data for various other things, like the relationship between researchers in different companies, spillovers to different companies, etc. The other thing I did with patents is, in an early paper, one question was always, what are patents? What's the value of a patent? One way to try and figure out the value of a patent is to see how much the patentees, the people that own the patents are willing to pay in order to renew the patents. So I built a model of that, related it to not only what the current returns to the patents are, but what the likely future returns to the patents would be. And we showed in that, or I showed in that model, that the patent values are extremely skewed. There's a few of them that are extremely high value, but many of them are very low value or no value, and got not renewed at very small costs very quickly. So this has then, the literature then took off from this to, for example, examine individual patents, the ones that were extremely valuable, or, as I said before, look at the patent document in more detail. The first thing, the future is very rich. There are a lot of very good young people in the field right now, and in fact, there are many other literatures, like the health economics literature, the environmental economic literature, part of the development literature, that are sending their students to industrial organization so that they can access these tools and use them in their own fields. My personal research has to do a lot with product development and investments. This part of the literature did not develop as much as the parts I had talked about earlier, partly because they are very complicated decision-making problems. How do I invest? Because to understand how my firm should invest, I have to understand what the other firms are doing also. And when you write down these models, they become very complicated. So we are now developing models which based more closely on actually how firms make decisions. That's simpler. Firms could not compute the things that the theory tells them to compute, and use those kind of models to analyze dynamic decisions like R&D decisions, research and development decisions, product development decisions, the amount of physical capital to purchase, etc.